So how exactly do you build something the size of a house and then guarantee it's going to work without a hitch for 40 years? It's an incredible engineering challenge. Today, we're going to unpack the literal blueprint for how it's done.
All right, so here's our roadmap. We're going to start with the sheer scale of the challenge, then dig into the philosophy you need to even attempt it. We'll look at the integrated system they use, follow a transformer's journey from start to finish, see how the system actually learns, and then we'll wrap it all up with the big takeaways.
First up, the high-stakes build. Because you really can't appreciate the elegance of the solution until you understand just how difficult the problem is.
I mean, this is the central question, isn't it? We're not talking about something that rolls off a standard assembly line. These are enormous, custom-built pieces of critical infrastructure. Failure just isn't an option. So, where do you even begin to guarantee perfection on that kind of scale?
Well, the source material is crystal clear about what quality even means in this context. It's not about a shiny coat of paint. It's about reliability, durability, and a long operational life. That's the holy trinity right there. It has to just work.
And to achieve that, you need a fundamental shift in how you think. This isn't about having a guy with a clipboard checking things at the end of the line. It has to be a core philosophy baked into everything you do. And here's the secret sauce. The goal isn't to get good at catching errors. The goal is to build a culture of prevention so robust that errors are designed out of the system from the very beginning. It makes quality everyone's job, not just one department's problem.
Now, that culture gets formalized into what's called a quality management system, or QMS. The best way to think of it is as the operating system for the entire business. It's the documented framework that sets the standards, measures everything, and weaves that quality-first mindset into the DNA of every single task.
So how do you build a QMS powerful? Well, the good news is you don't have to start from scratch. It's all about using a proven integrated blueprint.
And this is where it gets really smart. The solution isn't some top-secret proprietary method. It's about taking 3 globally recognized standards and fusing them into a single powerful system.
This visual explains it perfectly. You take ISO 9001, which is the gold standard for quality, and you fuse it together with ISO 14001 for environmental management and ISO 45001 for health and safety. The really revolutionary part here is the integration. It shatters the silos between departments. It forces everyone to see that product quality, environmental impact, and worker safety aren't separate issues. They're all deeply connected pieces of the same business risk puzzle.
And the benefits of doing this are huge. Audits become way more efficient, you get rid of tons of redundant paperwork, and communication just gets better. But most importantly, you end up with a truly holistic 360-degree view of all your business risks.
Okay, so we've got the philosophy and the blueprint. Now let's see how this whole system actually works in the real world by following a single transformer on its journey from idea to reality.
Whoa. Okay. At first glance, this flowchart is a lot. It looks incredibly complex, right? It shows every single step from the first customer phone call all the way to the final truck rolling out the door. But don't worry, as complicated as it looks, we're going to break it down into a few simple steps.
So that whole complex process really boils down to 5 key stages. It all starts with commercial, where you review risk before you even sign a deal. Then comes engineering, where the actual blueprint gets designed. Then procurement, making sure every single part from every supplier is perfect. Then, of course, production, the build itself. And finally, testing and dispatch, the final proof that it all works.
Now, of all those stages, the source material says the design phase is the most critical. This is where a system they call gate review comes into play, and you should really think of it like NASA mission control for quality. It ensures every single detail is perfect before your go for launch.
And this chart shows you exactly how that mission control works. The entire design process is broken down into phases. At the end of each phase, there's a gate. It's a formal review where a team makes a simple go/no-go decision. Nothing, and I mean nothing, moves to the next phase until it gets a perfect score. This is how you systematically squeeze risk out of the process step by step before it can ever snowball into a catastrophe.
So you have this incredibly tough process. But, things can still go wrong. A truly great system doesn't just prevent errors, it actually learns from them.
And this is absolutely essential. The system has a feedback loop built right in. Things like internal audits and what they call non-conformance records are used to capture any little deviation from the plan.
Think of a non-conformance record as the system's black box flight recorder. Anytime something isn't done exactly to spec, it's logged. And the point isn't to blame anyone, it's to ask, why did this happen? And how do we improve this system so it can't happen again?
To analyze that data and make real improvements, they use two famous methodologies. There's Six Sigma, which is all about using statistics to hunt down variations that lead to defects. And then there's lean manufacturing, which is all about eliminating any step in a process that doesn't add value. In other words, waste.
And Six Sigma isn't some kind of black magic. It's just a logical 5-step method. First, you define the problem with absolute clarity. Then, you measure the process to get the cold, hard data. Third, you analyze that data to find the true root cause. Fourth, you improve the process based on what you found. And finally, and this is key, you control the new process to make sure the fix sticks. It's called DMAIC, and it just works.
Okay, let's pull all of this together. We've seen the challenge, the philosophy, the integrated system, and how it all works in practice. So what's the big takeaway here?
Well, it really comes down to 4 key ideas. First, real quality is a proactive philosophy, not a reactive check at the end. Second, integrating your quality, environmental, and safety systems is a game changer for managing risk. Third, you can master incredible complexity with a structured, gated process. And finally, the best systems are designed to constantly learn and improve.
And that brings us to a final thought. This really isn't just about building transformers. It's a blueprint for excellence that could be used in any complex field. So the question to leave you with is this. If this level of systematic thinking can build a perfect house-sized machine, what complex problem in your world could you solve with a similar blueprint?